which center? Visakhapatnam, India. We do believe that one cannot replace the conventional and great teachers like Dr. Sarvepalli Radhakrishnan with these e-learning tools. After all, these e-learning facilities will add to the conventional teaching only. This chapter is aimed at introducing computers, programming, compilers, algorithms, etc. to the users. Before we delve into the details of all these terms, let me ask you a funny question. What makes anything as a computer? That is, what are the essential components to call anything as a computer? 1. Central processing unit, which is often called as a processor. And then memory, that is random access memory. These are the two things which are essential to call anything as a computer. In this figure, you can see that a central processing unit, memory, and the buses which connects these things. A bus is a set of lines which connects two parts used for communication between one part to another part. Data communication from one part to another part. You may see memory bus and also system bus. Bus, set of parallel lines which can be used to connect two devices. The processor contains the arithmetic logic unit, the control unit. In addition, it contains set of registers which are relatively very fast compared to even RAM also. However, the number of registers in a processor are usually limited. In addition to the CPU and the RAM, a typical computer contains other parts also, such as hard disk drives, CD-ROM drives, monitor, keyboard, modem, etc. You can verify in the figure a disk drive with disk controller, a monitor with a graphic adapter, and a mouse with a USB controller. Thus, these devices also can work together with the computer. These are all normally termed as peripheral devices. That is, they are add-ons only. We do have computers without monitor. We do have computers which works only by pen. There is no keyboard for them, like PDAs. The personal digital assistants, they use pen as an input device, no keyboard at all. Still, there are some computers which uses voice. So you can control the computer using your words. You need not require to enter data from the keyboard. So that way, we should say that these are all not compulsory. In order to call anything as a computer, which I have already mentioned, that the processor and RAM are the ones which are compulsory. Typically, all these devices, they can communicate with the processor. Whenever they wanted some service from the processor, they send a signal known as interrupt. Then the processor can give service for them. Some of them, they function with the help of DMA, direct memory access. which is a technology which makes the system little more efficient. In the figure, you may find a colored arrow which indicates data transfer from the disk controller to the CPU. The following is the figure of a watch computer. With this, you don't have any big monitor or keyboard. Thus, we can say that computers can be there without monitor and keyboard also. This figure shows a sample PDA, personal digital assistant. Here, with pen we can operate the computer. Thus, we need not require any keyboard with this one. Of course, they may have some facility to add keyboard if it is needed, but however, keyboard is not necessary. Thus, in practice, we may find computers without monitors, we may find computers without keyboards, etc. Thus, monitor, keyboard, etc. are not compulsory. They are all add-ons. They are all peripherals. In practice, computer employs variety of data transfers. Maybe from one register to another register, which are available in the processor itself. Maybe a register to a memory word, that is from register to RAM and vice versa. And also maybe a register to a device controller. So thus we have variety of instructions available with computers. We wanted to just give a little feeling how actual data transfer takes place. What are the steps involved? For example, let's consider a typical instruction, assembly language instruction. Move A, %EAX. Usually, in practical computers, the registers are referred with some symbolic names. EAX is a register name of a typical processor, such as RISC processor. A is some memory location, that is the RAM location. Move L, that indicates that move data transfer. We have to transfer between whatever available at the memory location A to the register EAX. In order to do this one, first the processor has to place the address of A, that is the memory location A. Where is it in the memory? Where is A is situated? Rather I say A is the address, memory location information. That location information is kept on the bus, which makes system to select the memory location of our interest. In the figure, we have shown a colored arrow to indicate that while selecting A, the data transfer takes place between the processor and the RAM. Now, whatever available at the memory location A in the RAM, that will be transferred from the bus to the interface unit. From that interface unit, the data will be transferred to the register EAX. Thus, the execution of the instruction MOVEL A %EAX involves this type of sub-operations, that is, placing the address on the address bus such a way that the memory location will be selected and then reading the data at that memory location, transferring to the interface unit, and then from that interface unit, data will be transferred to the register of our interest. Now let us try to understand how a data transfer takes place between the register to the RAM. That is, we wanted to transfer whatever it is available in a register to RAM. For example, the same can be done really in a typical processor with the following type of instruction. That is, move %EAX, A. Here, EAX indicates the register whose data we wanted to write into the memory. A is the memory location. Here also, you may find that first the memory location into which the data to be written has to be selected. Thus, on the address bus, first A location information is kept. Thus, a particular memory location will be selected for writing. And then the data transfer takes place. And then the data, whatever it is available in the register EAX, is first transferred to the interface unit. From that, it will be further transferred to the memory via the bus. Thus, we may find this type of data transfers also takes place between the registers and the memory. So like this, we have variety of data transfer statements at the low level, the instruction level. Basically, the processor supports this type of instructions. The following figures demonstrates how a data transfer takes place between the peripheral devices such as hard disk and the processor. We understood that a typical computer contains processor and random access memory. These are the two essential components. And other peripheral devices, these are all optionals. And we did indicate how really data transfer takes place between the memory and the processor, and also the processor and other peripheral devices. To run any program, it has to be loaded into memory. Then, instruction after instruction, the instructions are fetched from the memory to the processor, that is, to the registers of the processor, and then the instructions will be executed by the arithmetic logic unit with the help of the control unit. This is repeated till the end of the program is encountered. Mind it, when an instruction is executed, the results are normally available first in the registers, and then they will be saved to the memory, that is RAM also, because the number of registers available in a computer are limited. That is the reason why results of a typical instruction, they will be stored back again into the RAM. This is the nature of the computation, and this is how all the computers works. This style of computation, that is one processor and one RAM module, a program gets loaded into RAM, then executing one instruction after another till the end of the program. It is called as serial computing or sequential computing or von Neumann computing. Von Neumann is a person who designed the style of computing. However, unfortunately, in the history of computer science, somehow I feel that he did not get proper credit. Anyway, it's not the time to discuss more about him. So this type of computers are called as serial computers, sequential computers, or von Neumann computers. Mind it, here there will be one processor and one RAM module, and instruction after instruction, the instructions will be executed. However, there are some special category of computers known as parallel computers. Of course, it's a misnomer, wrongly people call supercomputers. But however, mind it that a parallel computer may not be necessarily a supercomputer. And also, a supercomputer may not be necessarily parallel computer also. However, usually the parallel computers are designed for application of supercomputing. The most important aspect here is there will be more than one processor. Instead of one processor, more than one processor and more than one RAM module. Then the program will be executed simultaneously on these processors. Remember, in the recent years or recent months, you are seeing advertisements about Intel dual core processor. AMD has announced quad core processor. Now, I think within another 2 years or so, Intel is going to release 80 core processor. So in one IC, you may find more than one CPU. I am talking in a layman way. Thus, a program can be executed in the fastest possible manner. Just to give you a feeling of what is meant by serial computing and what's meant by parallel computing, let me take a simple example. Let us assume that today I conduct an objective test. Then all of you will write the answers. Then I will collect the answer sheets. How do I evaluate? I can evaluate on my own. So I will take one answer sheet. Then I will correct question number 1, 2, 3 till question number 50. Then again I will take another answer sheet. Then correct question number 1, 2, 3 till 50. So this maybe I can say I am working in a sequential or serial fashion. That is, one after another I will be evaluating. However, let us assume that I have got an instruction from the higher ups saying that now you have to get the results within 10 minutes after the exam. How do I do it? One approach I can follow is I can call or I can request my colleagues to help me in evaluating the papers. Yet, I can also follow another approach. So what I shall do is, I believe you people, all the students, you don't do any mischief to me. So, with that assumption, I will shuffle all the answer sheets and distribute the answer sheets to everyone, such that one person gets one answer sheet. And I will make sure that that answer sheet doesn't belong to him or his friend. Somehow I manage it. And also I already said, I believe you people. So now I go to the blackboard. I'll write question number 1, answer A. What happens? Everyone will be working on question number 1 and verifying whether the answer there written by the student, is it correct or not? If it is correct, they will correct it. Otherwise, they will mark it as 0. Then I will go to question number 2 and say the answer is C. Now, all the people, all the students will be evaluating the sheets given to them. That is, they will see whether the question number 2 is correct or not in the given sheet to them. Like that, what is happening now? All these people, they are working on this evaluation. And the results may be available within 10 minutes. No doubt about it. Here, this is a good example for parallel task, parallel computing. All of you, all the students, they are slaves to me. When I say question number 1, you are correcting question number 1 only. When I say question number 2, you are correcting question number 2 only. However, only thing is, everyone will be working on the sheet that I call it the data. The same instruction, everyone will be working, but on different data items. In computer science, this structure of computing is called as single instruction and multiple data type. So it is just a good example for parallel computers. So these computers, they are not von Neumann type, non-von Neumann type. So especially this type of computer architectures are very much required for the development of real-time systems, where the system has to respond to you even within 500 nanoseconds. Let's consider a small example. Monitoring enemy aircrafts. So if your system, anti-gun, if it did not respond within 500 nanoseconds to an enemy aircraft, then that enemy aircraft may come and bombard you completely. So thus, the anti-aircraft management system, they should work, they should give entire response, entire service within 500 nanoseconds. That is, maybe within that fellow comes and bombards us, our cantonment, the anti-gun should do automatic action. In these applications, we do require to manipulate, process lot of information, lot of radar data. So there may be a single processor may not be adequate. Thus, we will go for more than one processor. We don't care about money, etc. We care about the response time. So thus, in this type of applications, we require very fast response. Thus, we may employ parallel computers. So there are some computers, parallel computers developed in India, such as Param-Padma by the CDAC Pune. Especially some application like atmospheric modeling, weather modeling, tsunami warning systems, aircraft monitoring systems, all these things, they require very fast response times. If the system doesn't respond within that time, some catastrophic things may take place. So thus, we do spend a lot of our money in developing special computer architectures for those applications. However, in this course, we will not be talking much about, or we will not be talking anything about programming such a type of computers. Whatever we are going to talk in this course are confined to serial computers only. So thus, in summary, most of our discussion of this course is confined to serial computer programming, that also C language program. So just now we understood that a computer essentially contains processor and RAM and other peripheral devices. I already clearly mentioned that the peripheral devices are not mandatory. We may in practice find computers without a keyboard, computers without a monitor, yet we can use them. Thus, these peripheral devices are add-ons only, they are not compulsories. Now the important question comes is, why do we require computers? Or why do we require to program? Of course, the funniest answer is to become little more lazy. No more than that. No doubt, if you have computer, you can do assign some of your work to it such a way that while that will be working, you can be lazy. You may be getting a doubt. What is meant by an operating system? Operating system is a system software which lies between the user and the complex hardware and masks the complexity of the hardware and gives clean and easy interface to the user. If it would have not been there, the user is supposed to learn machine language programming, then only he can avail the services of the machine. Nowadays, even a street killie shop fellow is also able to use a computer and generate a bill and giving it to us. The fellow may not be knowing even a little bit of computer also. Sometimes he may not be knowing even ABCD also. Still, he is able to generate the bill. That is because of the existence of the operating system. We can say that in the history of computer science, the annals of computer science, the great milestones are the development of the operating system. Remember, the Bill Gates became, till recently, unopposed millionaire in the world because of his operating system only, not for his MS Office. Thus, we can say the operating system development is great milestone in the development of computer science. Of course, the internet also. Usually, the operating system not only gives easy and clean interface to the user, but also it is a resource manager. It is supposed to manage the resources such as processor, memory, the disk drives and other peripheral devices among the competing users. Usually, the operating systems are developed to meet general requirements of the users. We know that for every user, there should be a freedom to create a file, to edit a file, to send the file to a friend through email, to print the file, etc. So the operating systems are designed to meet these general requirements. Whenever a customer finds some specific requirement, first he will check up whether it is available in the operating system or not. If not available, he will try to see are there any contemporary ready-made softwares available in the market which can be purchased off the shelf and installed on the top of the operating system and used. If not, then only he concludes that there is a need for software development such a way that that software can meet exclusively his requirements. Thus, the need for programming arises. For example, see an auditor who is supposed to prepare annual balance sheet. As such, if we install Windows XP or Windows 98, etc., they will not be having any tools to prepare a yearly annual balance sheet. Thus, he has to first check up in the market, are there any ready-made softwares? Yes, we have, such as Tally, WinCA, etc. So you can purchase one of them and install on the top of the Windows operating system. Thus, he can prepare annual balance sheet. Similarly, the customer happens to be a mechanical engineer. He wants to prepare a drawing of a part of a machine. Then, Windows alone will not satisfy his requirement. So thus, he may install AutoCAD on the top of it. Then, he will prepare the drawing of the part, whatever he wants to deal with. Thus, the customer is the one who has to identify that the operand system is not having whatever required for him, and also he has to identify there are no contemporary or ready-made softwares available in the market. Then only he concludes that there is a need for software development. Thus, the need for programming arises. We may be getting a doubt that is it possible to develop omnipotent operand system, that is, which can do whatever required for anyone in the world? No, we don't have such a type of operand system as of now. It's very difficult also to be developed. That is just because the customer's requirement changes from time to time. Let us say today we are having computers, we are having trains, thus we are having train reservation software. That is, we are having trains, thus we require some software to manage the reservations of the train. Let us go back to 300 years. That time we have bullock carts, and I assume that computers are available. Then what type of softwares do you require at that time? We require bullock cart reservation software. Thus, I say the customer requirements changes from time to time. Thus, having a omnipotent operand system is also impossible. Programming languages are divided into three styles. They are known as low-level languages and high-level languages and medium-level languages. What is the conceptual difference between high-level languages and low-level languages? High-level languages are uniquely identified by their rich grammar, whereas low-level languages will not be having any grammar. Of course, low-level languages will have having freedom to directly interact with the parts of the machine. And also, a low-level language program will be faster than an equivalent high-level language program. However, high-level language programs are portable, that is, the same program and the same efforts which can be used to on different type of machines. Thus, the programs written in high-level languages will be having more value. Take the following two statements, one C language statement and another assembly language statement. The C language statement A is equal to A minus B is self-complete. It indicates directly B to be subtracted from A and the results to be stored in A. Whereas in the case of assembly language statement, we do not know whether B to be subtracted from A or A to be subtracted from B, and where to store the results, in A or in B. Thus, we say that assembly language statement is relatively incomplete, whereas C language is self-complete. That is one of the important characteristics of the high-level languages, that is, they are self-complete, and that becomes possible because of the grammar. Maybe we, being human beings, we can identify the other meaning of the statement given by our friendly foe, whereas machine cannot do such a type of thing. It
can work in a unidirectional fashion only. Thus, grammar helps us in writing programs in single meaning. Multiple meanings is not possible because computer cannot have the ability like ourselves in identifying which meaning it has to follow. You may ask me a question that if my LKG teacher taught me in my LKG itself how to write things in zeros and ones, do I still require to learn C language? The answer will be yes. If you know to write things directly in zeros and ones, happily you can go and write the things indirectly in zeros and ones. Assemblers converts assembly language programs into machine language. Compilers converts high-level language programs into machine language. Both assembler and compilers, they will convert the programs into machine language only if the programs are free from language-wise mistakes. They cannot dare to check any logical mistakes in our program. Logic is our programmer's responsibility. Assemblers often we may get a doubt that are there any universal compilers or universal assemblers, that is omnipotent compilers and assemblers? No, we don't have any universal compiler or universal assembler. As such, for one high-level language or even for one assembly language also, we have a variety of compilers. For example, for C language, we have Turbo C, Borland C, Microsoft C compilers. Similarly, for the case of PC, we have NASM, TASM, MASM, etc. type of assemblers. That way, one should say that there is no availability of universal compiler. Having such a one is very difficult task. We will get the following types of errors while we are carrying out programming. One is compile time errors. They are also called as syntactical errors or language-wise errors. 2. Runtime errors. They are also called as bugs. 3. Computational errors. Compile time errors occurs while we are converting our high-level language program into machine language. Typically, they occur because of human errors. For example, sometimes we are supposed to put a semicolon at the end of a C language statement. If you forget it, we will get an error message saying that the semicolon missing. However, the error will be shown in the next statement in the case of C language. Similarly, whenever we violate the language rules, you will get this type of errors. When do we get runtime errors? They occur while program is running. Of course, these errors will occur because of many reasons. For example, if our program violates rules and regulations of the operating system while it is running, for example, trying to access a memory which is not allocated, simply our program will be terminated with an error message, probably memory segment violation, core dumped. Similarly, a situation like 1 by 0 or trying to calculating a square root of a negative number, etc. arises also, runtime error will come. And of course, when the operating system or system faces irrecoverable errors such as bus errors, etc. also, the program will be terminated, and these are all called as runtime errors because we get these errors while program is running. Just for the sake of demonstration, consider trying to calculating the square root of a discriminant function, that's ax square plus bx plus c. We assume that ABC values are given. B square minus 4ac square root we want to calculate. For example, if I give the data 141, the b square minus 4ac value will be square root of 12. We will get happily results as 3 point something. But if you would have entered data as 411, so then the square root value becomes negative number. Is the square root is different for the negative numbers? No. Thus, we will get an error, domain error. So you remember that the previous data 141, the program gives results, but if I present this 411 as the input data, then the program will not run. It gives an error message. This type of errors are called as runtime errors, are also called as bugs. Computational errors are the ones which will distort the final value or results of the program. Especially in some applications such as astronomy and in biology also, we require less computational errors. Otherwise, some catastrophic things may take place. Stages in the program development. 1. Developing the algorithm. 2. Preparing the flowchart. 3. Coding. 4. Testing and commissioning. What is an algorithm? Algorithm is a logical statement written in a normal usage language which contains approach for a problem. Of course, for one problem there can be more than one solutions. Whatever is the solution, if you write that one in normal usage language, it is called as algorithm. In fact, it is possible that for one problem multiple solutions are possible. In the case of data structures, we will try to find out which algorithm, for example, which sorting algorithm is better in computational point of view. That is the essence of the data structures course. That way, I should say, for one algorithm, one problem, there can be more than one solution. Whatever is the solution, if that solution is written in normal usage language, it is called as algorithm. I wanted to write an algorithm which reads 3 integers and calculates the maximum of them. No doubt, for this purpose, we can write more than one algorithm. However, I am trying to explain about one approach for this problem. The same thing is represented in the algorithmic fashion. So let us assume that whatever numbers I entered are being stored in this variables a, b, c. If a is greater than b and c, then I can say a is the largest out of all these three. Otherwise, I compare b and c, because if a is not larger than b and c, then definitely a is not the largest out of all the three numbers. Thus, I compare b and c. If b is greater than c, then I can say b is the largest of all the three numbers. Otherwise, I can say c is the largest of all the three numbers. If you verify the previous slide, we may find an algorithm for this problem, that is finding out the largest of the three numbers. That is, it is looking like more like English. It doesn't contain anything specific to any particular language, either C or Pascal or COBOL. Thus, algorithm is independent of the programming language. Now, the question comes is, what is a flowchart? Flowchart is a pictorial representation of the algorithm, such a way that we can find out any mistakes in our thought process while developing the algorithms. Of course, it can be used for analyzing the algorithm. Flow analysis we call. For that purpose also, a flowchart can be used. We shall explain in the next slides what's meant by. The following symbols are used while preparing the flowcharts worldwide. The oval indicates the start and stop symbols. Square or rectangular indicates just simple processing. Input-output is indicated by the parallelogram. Decision making is indicated by the rhombus. And circle is used to join the two or more flowchart segments. Arrow is used to indicate the program flow. This is the flowchart for finding out the maximum of the three numbers. We assume that the user has entered values 18, 9 and 10. Is A greater than both B and C? That is, this condition is checked. Yes. 18 is greater than both 9 and C? Yes. Thus, the program execution follows that green arrow. Now, A value will be printed and then program terminates. Now, let us assume that user is entered 18, 91 and 10. Is A greater than both B and C? That is 18 greater than 91 and 10? No. Then the program execution comes towards that green arrow. Is B greater than C? That is 91 greater than 10? Yes. Thus, the program execution now follows that green arrow. B will be printed and then program execution switches to ending. Now let us assume that the user has entered 18, 91 and 100. Is 18 greater than 91 and 100? That is A greater than both B and C? No. Thus the program execution comes towards that green arrow. Is B greater than C? That is 91 greater than 100? No. Thus C value will be printed as 100 will be printed and program execution ends. Let us assume now we wanted to write an algorithm to find out average of a class. We assume that initially the student will be asked to, user will be asked to enter number of students. Then initially sum is assumed to be 0. A variable value, I variable value will be assumed to be 0. Then we will read a number, plus marks, add it to the sum and increment the I value by 1. If I is less than n, then we again go and read the next student marks. This we repeat till I value becomes n. You can find flowchart for this algorithm. We assume that the user has entered 5 and some value and I value are initially made as zeros. Some value 50 is added to sum, thus sum becomes 50. I value is incremented by 1, thus I value becomes 1. Now I value 1 indicates indirectly that as of now we have read 1 student marks. Is I value 1 less than n, that is 5? Yes. Thus again the loop will be executed, that is one more student marks will be read and then will be added to the sum and I will be incremented by 1. Now I value is 2, that is as of now we have read 2 students marks. Still some more students marks we are supposed to read. I less than n? Yes. Thus again we will go and read 1 more student marks and add it to the sum. Currently I value is 3, that is as of now we read 3 students marks. Do we require to read some more students marks? Yes. I less than n? Yes. That indicates that still there are some more students whose marks will be read and added to the sum. Thus the loop again executes once more. 1 more student marks will be read, added to the sum, and again I value will be incremented by 1. I value is now 4, which indicates as of now we read 4 students marks. Still, are there any more students whose marks to be read? Yes. I less than 5? Yes. That indicates that there is still some more students whose marks to be read now. Thus again loop will be executed once more. I value 5 now. That indicates we have read 5 students marks. What is the value of n? 5. Which means that we are supposed to read 5 students marks. Already we read 5 students marks. I, is it less than n? No. Which indicates that the loop is not going to be executed. The program execution goes to next statement, that is calculating the average and printing the same. From our previous examples on algorithms and flowcharts and their analysis, we can understand that flowcharts are very useful to analyze a program flow. You might have understood already how we have analyzed by giving some sample data. They are very useful in correcting any mistakes in our thought process while preparing the flow algorithms. So thus this gives us a mental picture about how a piece of logic works also. Thus I say flowcharts are very much useful to understand how a piece of code runs. As of now we understood that while developing a program, we may have to first write an algorithm, then a flowchart, analyze the flowchart, and any mistakes are there in our thought process while writing the algorithm, try to correct it, and then the concept of coding comes into picture. Now the important aspect comes into picture is which programming language should I select? Do I select C or do I select Pascal, etc.? Of course, no doubt, the selection of the programming language is also very important, but very often it is very much controlled by the customer. Sometimes customer comes to us and says that you have to develop the program in C language alone. Then we will not be having any option left with us except developing the things in C language. But if the customer doesn't put any restriction on us, then we have plethora of options. Languages, they have some characteristics which makes them very much suitable for some applications. For example, C language even still is used very widely for system software development. Similarly, for BASIC, still it is used for the teaching purpose, and whereas for the graphic applications, Pascal, C++ are very much used. For network applications, Java is being used, and now the .NET is very much dominantly used for the internet related systems development. That way, I should say the selection of the language is very much influenced by the characteristics of the language and the application concerned and the customer also. If the customer says you have to develop in the C language, then you will not be having any option left with us except developing the things in C language. What are the characteristics of the C language? This doubt very often people get, because previous slide we have discussed about the languages and their characteristics and their suitability for some applications. Normally, C language has both the flavors of high-level language and low-level languages. That is, it has a rich grammar and structure with which we can develop marvelous applications. It is being used for system software development, and also it is used for the graphics applications. It has been used for a variety of applications because of these characteristics. In practice, we have a variety of C language compilers. We can say that few thousands of compilers are available for C language. In fact, if you are being properly educated towards real computer science, you should be in a position to develop your own C language compiler once you complete your 4 years BE or BTech or BS. However, I should just recall some of the C language compilers names. No doubt, all the compilers, they accept C language programs, but however, they do have some marketing strategies. That is, in order to market their product, they add some ready-made programs and sell it. However, if we develop our programs using these ready-made programs, then our program may lack portability. It is very much recommended that we have to develop the programs in strictly ANSI C fashion rather than developing a compiler specific style. We have C language compilers for DOS and Windows platforms such as Turbo C, Borland C, Microsoft C, Jotex C, Speed C, and DJGPP. Similarly, we do have variety of C language compilers for Unix Linux platforms like Sun OS C, MIPS C, Iris C, then GNU CC. So this GNU CC is becoming day by day very popular and has been very much widely used for even embedded systems, and has been used very much evidently for space-borne systems development also. In general, the coding involves first typing a program. For this purpose, we may use some editor. For example, even we can use Notepad also. Even we can use edit command of DOS also, or even cat command of Linux also one can use it. Of course, if you happen to use some IDEs like integrated development environments like Turbo C IDE or Borland IDE, etc., the editor is available inbuilt. So we don't require to worry much about this one. However, in the next classes we understand about Turbo C editor and VI editor of Unix, etc. So we have to use some editor and type whatever C language program we wanted. We have to type that one first. Then we have to save it. Then we have to compile it. Then we have to test it. Once testing passes through all the stages, then we can implement in the practice. In the following slides, we try to explain about how a program gets executed. Already we understood that we have to type a program. Those programs are called as source programs. They are the basis for entire subprogram development. They are first created. The source program means they can be C language programs, they can be Pascal or C++ or Java, anything which are normally typed by the user. They are called as a source programs. Of course, some extra header files also called as sources. Even some other configuration files are also called as sources. All of them will be created initially. Then these source programs are being taken by the compiler, and that converts the source programs into object files. Of course, when it converts, only if our source programs contains 0 syntactical errors, that is, there should not be any language wise errors, then only the compiler converts our program into object files. They are also called as normally intermediate files in the case of C computer science terminology. We said already that the compiler vendors, they will supply some ready-made programs which we can call them as libraries. We can develop our C language programs using the ready-made programs which are available with the compiler. That is, the functions whatever available in the libraries can be used in our C language program. Mind it, they are not developed by us. And also remember that we have to include appropriate header file whenever you wanted to use those ready-made functions. Normally, the libraries contains the ready-made functions, that is, their machine language files only. So the linkage editor, or simply we can call as linker, what it does is, it takes these library functions from the libraries and extracts them and attaches to our object file and gives a fully runnable machine language file. We can call them as a .out file in the case of Unix environment, whereas in the case of Turbo C environment it is called as a executable file, exe file. So that is normally saved into the disk. So that is the executable file. That is the one tomorrow if you wanted to sell, you are supposed to sell. Of course, there are two types of software distributions known as binary distributions and source distributions. If you supply the executable files, then it is called as a binary distributions, which means that the user will not be having any freedom to modify them further. He has to use whatever it is available, whatever is supplied by you. Whereas, if we supply them directly, the developed C language programs, they are supplied to the customer, then we call it as the software is distributed in source fashion. This time, the customer will have a lot of freedom because the sources are available, he can modify, he can redesign, whatever he wants you can do. But however, in general, the source distributions are very costly compared to the binary distributions. Just for example, what Bill Gates is supplying for us is the sources? No. He is supplying only executable files. If you would have supplied source programs, they are directly C++, Visual C++ programs, whatever he has developed or his team has developed, that's it. I am sure that tomorrow you will pull his Microsoft logo and you put your face there, you release another Windows system of your own. However, he is not a fool. He is safe because he is supplying the binary distributions. So thus, the linkage editor creates a fully executable program. Once the executable file is available, the loader takes the responsibility of loading our program into the freely available part of the memory, that is RAM, and then it starts executing our program. For the sake of completeness, we are having this figure. Here we have shown that there is a disk where the executable file hello is available. Whenever we start that program via the disk controller, it will be loaded into main memory and then it will be executed. Previously, we did discuss that how a program will be executed. We did show the instructions, how they will be transferred from the main memory to the processor, and how the things are copied back to the processor to main memory, etc. So once the program is loaded into main memory, one instruction after another, the instructions are fetched from the main memory to the processor, and they will be executed one by one till the end of the program is encountered. That's how this is the total picture of how a program, independent of the C language program or any other program, it is going to get executed. That is, first a source program we have to develop it, then we have to compile it, and if it is required, the compiler will link with the readily available functions, and then it creates a fully executable program. Then the loader takes the responsibility of loading this one into the RAM, and then that will be executed one instruction after another. So this is how a total picture, this is the total picture of how a program gets executed. In this lecture, we have explained about what is a computer, what is a programming language, why do we require to program, what is an operating system, what is a compiler, what is an assembler, how a source program will be finally converted into machine language program and executed, etc. aspects. In the following lectures, we will try to explain about how really programming can be done under Turbo C environment and Unix environment. Thank you for bearing me for this lecture.